Hello, welcome to Talk Math. Today we're going to be doing the 1986 AIME problem number 11. Now this problem reads the polynomial 1 minus x plus x squared minus x cubed up until plus x to the 16th minus x to the 17th may be written in the form a0 plus a1y plus a2y squared plus a3y squared up until a16y to the 16th plus a17y to the 17th, where y equals x plus 1 and ai's are constants. Find the value of a2. So let's try to grasp what this is saying. So we know this polynomial can be rewritten as this polynomial by the substitution y equals x plus 1, or rewriting we get x equals y minus 1. So if we were to plug in y minus 1 for all the x's here and expanded that out to get this polynomial, we want to solve for what a2 is. Well, let's start by subbing y minus 1 into there. So 1 minus y minus 1 plus y minus 1 squared minus y minus 1 cubed, and so on, up until plus y minus 1 to the 16th minus y minus 1 to the 17th. Now, I see that we have a whole bunch of pluses right here, but we are alternating plus minus. So I'm thinking what happens if I distribute this negative inside each of these parentheses to make this a 1 minus y and that a plus. And then because this is even right here, we can actually do the same thing to this and make this a 1 minus y just because the negative sign will get squared away. And we can repeat that same thing going all the way down. So I'm going to rewrite this, I guess, as a new one. So we have 1 plus 1 minus y plus 1 minus y squared plus 1 minus y cubed, so on, up until 1 minus y to the 16th plus 1 minus y to the 17th. Now all we need to do is find the coefficient of y squared. Well, in these two terms, there is no y squared, so we ignore those. Here, using the binomial theorem, we can rewrite this as 2 combination 2. The coefficient of the y squared term will be 2 combination 2 times 1 to the 0th times negative y squared. Now, in this term, using binomial theorem, it will be 3 combination 2, 1 to the first power, and then we have negative y squared. Okay, and then we can keep going up until over here, we'll have 16 combination 2. Then we have a negative, we're going to still have a negative y squared in every term, so you have a negative y squared, and then the 1's will be a 1 to the 14th power. And now finally, we'll have a plus 17 combination 2 times negative y squared and 1 to the 15th. Now, if you notice this 1 to the any power in all these terms is just going to go away because it's 1. So we really just have, and this negative will get squared out in every single term. So we really just have y squared times 2 combination 2 plus 2 combination 3 plus 2 combination 4, so on, until we get to, sorry, I wrote these backwards. This should be 3 combination 2, 4 combination 2, up until we get to 17 combination 2. And that is this term in the new polynomial. So how do we evaluate this? Well, this can be recognized as the hockey stick theorem, where if we were to write out Pascal's triangle, the way the hockey stick theorem works is that if we wanted to add up these 3, or sorry, I'll go one more row. So let's say 1, 5, 10, 10, 5, 1. If you wanted to add up these 4 numbers, the hockey stick theorem says that it'll just look like it'll go there. And it's called hockey stick because that looks like a hockey stick. And this works on any diagonal. Sorry. So, for example, if we wanted to add up 1 plus 4 plus 10 plus 20, then by hockey stick, that would give us the next number being right here, which is going to be a 35. And we can rewrite these as combinations. Really, this is saying that 1 combination 1 plus 2 combination 1 combination 0 plus 2 combination 1 plus 3 combination 2 plus 4 combination 3, that's equal to 5 combination 3. And that is what the hockey stick says. Now, this right here is really the same thing, just going the other way. So if we wanted to add up these, then that would be saying that 1 combination 1 plus 2 combination 1 plus 3 combination 1 plus 4 combination 1 plus 5 combination 1 is going to give us this right here, which is a 6 combination 2. So this can be proved in multiple different ways. So looking at this, we see this is just the same thing going into, we have 2 combination 2, which is right here, and then we have 3 combination 2, and we have 4 combination 2, so we have all of these going all the way to the 17th, choose 2, and then we're going to go the 1 diagonal. So this is really equal to y squared times 18. See, if we notice this increased by 1 and that increased by 1, so times 18 combination 3. Well, all we need to do is find the coefficient, so we need to calculate 18 combination 3, which is 18 times 17 times 16 over 6. So that comes out giving us a 3, which is saying is 48 times 17, so 56. 7 times 4 is 28, so that becomes 33, 0, 8, 4. Adding up, we get 5. Sorry, I wrote that wrong. That's a 6. Whoops. Sorry about that. So we get 6, 1, 1, 8, and 8, 16, and that is the answer, and we are done. So this problem wasn't too bad once we realized that we could rewrite all the polynomials in a nice way and then use this hockey stick theorem, which if you're taking the AIME, you should already know what that is. So you should immediately be able to recognize that this is the same thing as 18 combination 3. And then once you have this, it's not bad to come up with the final answer, 8, 16. Thank you for watching. I really hope you enjoyed the video. Please like and subscribe if you want to see more.